Alright, angle P and Q is inscribed in circle O, and measure of RPQ is 70 degrees. So that's 70 degrees, which tells me the central angle is 70 degrees. So the measure of POQ is 70 because of the central angle. What is the relationship between POQ and PNQ? They both share the same arc. Alright. What is the measure of PNQ? PNQ is an inscribed angle on the circle, so it is half the arc, so 70, which is 35. And the circle P below AB is the diameter. So that means that this is 180, which makes this 90 degrees. This is 180. It says that if measure of APC is 100 degrees, find the following. APC is 100, so that automatically tells me that BPC right here is going to be 80, because straight line makes 180 degrees, so that'd be 180 minus 100, which gave me 80. Alright, BAC. Alright, since we're going to find BAC right here, we know that if this central angle is 80, then that makes this arc 80. Well, this is an inscribed angle, so it is half of 80. So 80 divided by 2 gives me 40. Alright, arc BC. Alright, since we know this central angle is 100, that means that, that'd be AC. Will be 100 for AC. And we also know that BC right here will be 80. Alright, circle P below. DG is a tangent. AF is 8. EF is 6. BF is 4, and EG is 8. Notice that I've already labeled those. You can label those as well. So we're trying to find CF and GD, or DG. So right here, for the first one, I say 8 outside times the whole thing, because it's secant and a tangent. So the whole thing would be 8 plus 6 plus 4. Alright. Will give me 18. Alright. And so then I come down here, and I know this side is X times the whole thing, so it'll be X times X, because we know it's outside times the whole line, so the whole line's still X, so that'll be X squared. 18 times 8 is 144. Take the square root. Opposite of squared would be 12. So DG is 12. For the other one here, you just multiply segment times segment, because they're two chords. 6 times 4, 8 times X. 24 equals 8X. Divided by 8. Into 24. X equals 3. So CF is 3. And the circle AB is a tangent to the circle at point B. AC is tangent to the circle at point C. And point D lies on the circle. What is measure of angle BAC? So we're trying to find this angle right here. We already know that when these tangents meet that angle, they form 90-degree angles, which tells me that these two are supplementary. So I know I can find this arc up here by doubling 48. So I say 48 times 2 gives me 96. So I know that this arc is 96, which also tells me this angle is 96. Alright. So now I have 96 is this arc up here. And I have subtract 96 from 360, 264. And now I have arc, because I got a secant and tangent on the outside. So I just use my arc minus arc divided by 2. 264 minus 96, arc minus arc, divided by 2 gives me 84 for that angle. Now, there's another way we can think about this. So we know these two make 90. That means that these two also have to make, these two make 180, because 90 plus 90 is 180. I know that this is 96. All I gotta do is say 180 minus 96 gives me 84. So there's two ways you can look at it. Circle P is dilated to form circle P prime, which statement is always true. The ratio of the diameter to the circumference is the same on both circles. So we know that there are proportional ratios between the diameter and the circumference. In the circle shown, BC is the diameter. Measure of AB is 120. If we know this, if this is the diameter, then that means that this arc is 180. So all we gotta do is say 180 minus 120, and that'll give us this arc of 60. And then divide it by 2 and get 30. Because we know that angle equals 1/2 the arc. Alright, circle A tells us x is 50. What is the area of the shaded sector of the circle A? So I'm going to use my formula, say 50 over 360, because that's the portion that we're finding. Find the area of my whole circle. So I'm going to say power squared, so I got 8 squared is 64 pi. 50 over 360 times 64 pi gives me 80 over 9 pi. It's approximately 27.93 meters squared. This is just an alternate way to do it. 50 over 360 over equals x over pi r squared. And then I get 64, and multiply both sides by 64 pi. Multiply this side by 64 pi. I get the same exact answer. Circle E is shown. What is the length of CD? So I know we're finding arc length here, and I did it the alternate way I did a minute ago. We're given the radius, so we know we're doing circumference equals 2 pi r. 145 over 360 equals x over 2 pi r, which is 2 pi 12, because our radius is 12. 12 times 2 is 24. 24, multiply both sides by 24 pi, and you get 29 over 3 pi yards. Alright, next one, the spokes of a bicycle wheel form 10 congruent central angles. The diameter of the circle formed by the outer edge of the wheel is 18 inches. What is the length of the nearest 10th inch of the outer edge of the wheel? 2 consecutive spokes. So we're trying to find the length of the arc. So we're given the diameter, so we know we're going to use circumference equals pi d. So we set it up. We know that since the whole circle is 360, there's 10 equal parts. So I'm going to say 360 divided by 10 gives me 36 degrees for the central angle and the arcs. Alright. So now we do 36 over 360 equals x over 18 pi. multiply by 18 pi. 18 pi times 36 over 360 is 9 over 5 pi, approximately 5.7 inches. Circle Y is shown. What is the area of the shaded part of the circle? So, in order to find the shaded arc, I know that's 75 for that arc. So to find the other arc, I just say 360 minus 75 is 285. So I got 285 over 360. And I'm going to use area equals pi r squared. So I plug in my radius, which is 9. So I got 9 squared, which is 81 pi. And then I multiply by 81 pi. 81 times 285 over 360 gives me 513 over 8 pi centimeters squared. This next part, circle A, B, and C have a central angle measuring 100 degrees. The lengths of the radius and intercepted arcs are shown. What is the ratio of the radius in circle B to circle A? It's 10 over 7. 10 over 7. What is the ratio of the length of the intercepted arc of circle B and the length of the intercepted arc of circle A? So I'll put 50 over 9 pi over 35 over 9 pi multiplied by the reciprocal. Cross out my pi's. End up with 50 over 9 times 9 over 5. Cross out my 9's. 50 over 35 is 10 over 7. And compare them, and they are the same. What is the ratio of the radius in circle C to radius in circle B? 6 over 5. Same to do with the arcs in my next question. So that'd be 20 over 3 pi over 50 over 9 pi. Cross out my pi's. Multiply by the reciprocal. Alright, cross cancel. So I know 3 goes into 3 one time. 3 goes into 9 3 times. 10 goes into 22. 10 goes into 55, so that'd be 2 times 3 is 6. 5 times 1 is 5. 6 over 5. And they're the same. Based on your observations, circle A, B, and C, what can you make about the lengths of the arc intercepting the central angle and the radius? Since the central angles are the same, then the arc lengths and the radiuses are proportional or similar. And then you look at, says, what is the ratio of arc length to radius for each circle? So I put the arc lengths over the radiuses of each circle. Simplified them in my calculator, and they all equal the same. So the scale factor would be 5 over 9 pi. Alright, that's your study guide.